Hey folks, thanks everyone for coming today. My name is Gustavo Pantuza, and I would like to share with you how you leverage Open Telemetry collectors and protocol to create a observability solution that is able to ingest 6.5 terabytes of the telemetry data per day. Well, I can't believe they let me get away with this huge presentation title, so thanks, Coll, for that. I'm the tech lead manager for the observability team inside Vitex. I also have previously worked for GoDaddy and also for Global.com. It's sort of Netflix from South America. Those are my handles for GitHub and Twitter, so if you would like to reach out. I also write about computer science topics on my personal blog in Brazilian Portuguese, so we can strengthen our local community of computer science. Well, let's jump into the agenda for this presentation. And first, I would like to share with you what kind of system are we observing, right? So what is Vitex about? So inside this context, where is the problem? Which problem are we trying to solve? And then, before jumping into the details of the architecture and solution, just briefly state what is the solution and the outcomes we reached with this solution. Then we jump into the architectural part, where I would like to share with you how we are implementing those things, and also talking about resilience of this solution. So how we avoid outages and keep these things up and running. So what is the system are we observing? Vitex is a digital, enterprise digital commerce platform where customers can build, manage it, and deliver their online stores. It's a multi-tenant platform, so we have a single platform where the brands come and deliver their stores using this shared platform. We have today 3,200 online stores, delivered over 38 countries, alongside 38 countries. Also, we are up to 1.3 thousand employees over 18 locations around the globe. So where is the problem in this recalling? We are talking about a multi-tenant e-commerce platform. So we have only a single observability use it to have only a single observability vendor system for logging and so on. And all of the applications alongside all modules inside this e-commerce platform, they use it to send code, telemetry data directly to this single place vendor and observability system. Well, within this context of having this centralized place, we have too many implementations, libraries for communicating with this vendor, with this solution, and none of them has common things like fields and also resilience controls that would be nice across all of the teams, not by different teams. Also, the data governance, whether businesses, person, also engineers get together in the same place and was able to reach some sort of telemetry data that sometimes we would like to have a more granular governance. Also, when it comes to KPIs, let's say for business metrics, teams use it to do queries and analytical stuff on top of a logging solution. So it was not the best place for it, so we would like to split those things and understand better and give better solutions for analytical stuff. Also, not a single vendor is able to get the best solution for all of the telemetry, for each of the telemetry data. So for us as well, it was something like we have logs, metrics, and traces, and there is no vendor, in our opinion, which is the best one for each one of them, for all of them together. Also, an inefficient ingestion control, whether single proxy, just sending data to this observability system elsewhere, and no control such as sampling, for example. Also, the libraries, they use it to be written over HTTP 1.1 with no encryption on it. Also, data was going through this pipeline as raw strings, unstructured logs, also some sort of metrics, and trying to do traces on top of our logging systems. And also, no common fields spreads alongside the teams and engineering teams. So all of those problems together, if I could state as in a tweet or something like that, what kind of problem are we trying to solve? It is how to evolve to a long-term observability solution without vendor lock-in while improving the efficiency of our observability stack. So this is the statement it states the problem. And on top of, based on this problem, what is the solution? I would like to start drafting this solution by showing a diagram, which is kind of compile everything in a single image. And afterwards, we are going to jump into the details. So for this first image, in the rows, you can see the telemetry signals. And as columns, you can see from the left to the right, the application source code, where the telemetry starts. And then they all goes to Open Telemetry collectors. We are going to talk more in depth about those deployments of Open Telemetry collectors, because they are different for each telemetry signal. And then we have the data sinks. So in this architecture, we are now using as data sink for logs. We are using AWS Managed OpenSearch. For metrics, we are using the AMP, AWS Managed Prometheus. And for traces, we are using Honeycomb. And in all of those three, we can do visualization of the data, but also we try as much to centralize things that are common and shared among all teams, or that are, let's say, common dashboards, for example, into Grafana. Also alerting. All right, so what are the premises in this solution? Basically, Open Telemetry Protocol on every possible layer. So from the origin in the libraries, we are going to talk about it, but as you can see in the previous image, we have diagnostics library, which is a library we built internally on the company, which goes as Open Telemetry Protocol since the beginning of the request data flow and so on. So Open Telemetry Protocol on every possible layer. Also trying to create common library interfaces where teams can have the same sort of interface while implementing and while sending telemetry data over the pipeline. Using Open Telemetry collectors is one ideal part for getting into the ingestion point for every telemetry signal. Even logs, we are going to talk about it, but everything goes through the Open Telemetry collectors, so we can then export them to the proper data sink. And for each telemetry signal, as I stated before, we believe that not a single vendor is able to handle in the best possible way all of the telemetry signal, so we decided to go with different vendors for each telemetry signal. Also, for increasing our ability to keep things up and running, we created a sharded architecture for this solution. I will jump into this as well further. All right, what were the outcomes after deploying this solution? First, on the slice of our cloud investments, we were able to reduce 41% of our observability costs. Also, delivering a long-term solution, whether developers at the end of the day doesn't have to change or do deployments or migration if we change vendors in the data sinks. Because we have a library in place, we can simply say, okay, you're sending telemetry data over Open Telemetry Protocol, and if we change the backend, we change something in the observability team. But we don't require engineers to migrate anything from the source origin. So it allows us to evolve and innovate fast. Also today, and moving further, this solution is able to handle, and we are ingesting today 6.5 terabytes per day of telemetry data. Well, let's jump into the architectural part of this solution, and then let's start by the library. We have designed an interface, whether just, for example, like engineer can say, hey, logger.info.warn.debug or system metric. a common interface where we could implement in various languages. Those are the top 3 languages within the company. So we developed the same library. We have the diagnostics library for each one of those languages. And we were able to create common code. For example, resilience control, back-off, retries, circuit breaks, and so on a single place. Also, asynchronous communication, and enforce some of the things like Open Telemetry Protocol and gRPC in place. Here is an example of the common interface, just out of curiosity. So the libraries implement those interfaces, and engineers, as our customers from observability, can implement and send telemetry data using the same interface. Also, we delivered a common fields, like all sort of telemetry data. We have common fields that they can come built in with the library, and sometimes for the developers to add it by themselves, those data inside the telemetry payload. So it's nice when it comes to the visualization part, because they can correlate things based on those common fields and things that are sensible to the business's part. Well, let's jump a little bit on the deployment for the collectors, the middle part on the previous diagram architecture. So the first thing I would like to mention in this deployment are the Open Telemetry collectors. They are simply a deployment inside a Kubernetes where we run collectors inside containers, and then they are able to handle the ingestion part of the telemetry data they are sending, whether it is from logs, metrics, or traces. This is pretty much the same kind of deployment for all of the collectors. The configuration part, which is the part that will be different for each one of the telemetry signals, pipelines. So the second part in this architecture, it's a very straightforward way of doing ingestion, like ingress part or the networking part on this architecture. So it's simply using a load balancer, issue, external DNS plugin just to update how the library will be reaching the internal service inside Kubernetes. And everything is managed by Argo CD, which is where we change configurations for issue, external DNS, or even collectors. So everything we update, it goes onto a pipeline, and then Argo CD is responsible to deploy and put those things in production to us. Well, moving further, how we build our collectors, because we use a custom collector. We write extensions for the Open Telemetry collectors. We use the Open Telemetry collector builder for it. So we build our own binary. So in our pipeline, what we have is we have a bunch of source code where we extend Open Telemetry collectors. And then we have this pipeline where we build the binary, then we create a container image, and then we notify Argo CD for triggering the deployment, and then Kubernetes is responsible to do the progressive rollout for us. So this is pretty much how we put our collectors binary in production. And here's an example of how we build Open Telemetry Collector. If you are familiar with Open Telemetry Collector Builder, this is pretty much what you have inside an YAML file, and those are the parts that are important to us. So in every one of those layers, those 4 layers, we have private code running as if we implemented receivers for specialized use cases internally, also exporters for internal systems or other vendors or other systems that we need to communicate with and send telemetry data over. Also the processors, which are a special part for us because it's a way we can manipulate data on the fly. So telemetry data goes over the collectors, we can manipulate this data and then take decisions where we can do something. So one example for it is sampling. I will speak more about it in the resilience part on this presentation. So here's the telemetry data flow to try to simplify things. Imagine, so the telemetry data flows from the diagnostics library, and depending on the DNS, if the developer is saying, hey, logger.error, we know this is a log, and then it goes over the proper URL that is able to reach the load balancer in front of this entire Kubernetes cluster, which is responsible for the logs part, the logs pipeline, and then it gets ingested, processed, and then exported to OpenSearch. The same flow goes for metrics and traces. And when it comes to visualization, we have the role of Grafana. Grafana, as I mentioned, we use it to reusable dashboards and central dashboards and common dashboards for engineers. So they are able to create their own dashboards, but we also have the ability to have common things, and they, let's say, get things out of the box just because we have Grafana and can create templates and so on. They also can use and create visualization, specialized visualizations directly on OpenSearch, AMP, and Honeycomb. So we have the governance for teams and team engineers all over, depending on SSO from the company. So we have groups and ability to create roles and permissions for teams and types of different users to have access to different types of data. Well, just to reinforce the diagram, after going through the architectural part, just to recall how we designed this architecture. Well, with this solution today, we have 4 terabytes of logs going to OpenSearch. We have 150 million active time series going to AMP today. And here it's important to mention that even business metrics, sometimes we are sending them there, and we are able to have high cardinality on some of all those metrics, which is something important, we know. And also, when it comes to traces, we are ingesting today 2.15 billion individual events on Honeycomb. All right, let's jump and talk about resilience. Well, with this architecture, we have to make it work, make it stay up and running. So one of the premises we have for this solution is to fail locally and not globally. So, and when I say it, imagine a scenario where I can lose a collector or one of the data sinks, and also some ingestion in the origin that goes wrong. So with that, what we mentioned, designing with this architecture for fail locally. So if sometimes I lose one collector for the logs part, okay, I can say and communicate to the engineering teams, hey, we have an outage of observability, but this outage is only for logs. We still have metrics and traces. And in the previous scenario, we use it to have, when we have outages for observability, probably the teams have no observability at all. So it was a problem for engineers. So by breaking those things into different pipelines, and I will talk about sharding as well, we can have a way for failing locally, and it's easier as well to communicate with engineers. Another thing for resilience is the pod outscaling, pretty much regular stuff for Kubernetes. But here, I have to state that for different deployments, we have different configurations. So the log ingestion behavior is different from the traces ingestion behavior. The types of machines, the way we do autoscaling, they are different from depending on the telemetry data. So this was one of the important parts as well for resilience. As I mentioned, we have shards. Well, they are businesses-driven decisions on how we shard, but I would like to share something like, imagine, as I mentioned, a multi-tenant platform for e-commerce, and then we have several internal systems, but also modules and code. So some of them are core systems, and they should not fail or should not lose observability. And also, there are other small APIs, backend systems that are just supportive for the main applications. So in this case, we can split them into shards, so then we can avoid losing telemetry or observability for the core systems, for example. So I not only have the 3 telemetry separations like logs, metrics, and traces, but we also have shards. So when it comes to failure, I can lose the shard 1 for the logs pipeline. So it's even more locally than globally when it comes to fail. So it helps as well showing the engineers, hey, we have an outage for the logs pipeline, but only for shard 1. You probably might not be affected if you are not in this shard. So this is another way of failing locally and improving our observability. Well, another thing, it's one of our extensions. We allow teams to sample logs. So error logs doesn't get sampled. But if you're sending logger.info or success logs, we just sample. We have this configuration. We implemented this extension for collectors. We allow teams to individually say, hey, this is my index, my index name. I allow you to sample me by this percentage. So in this example, we have a team that's saying, okay, sample me by 75%, but in another case, we have 0%. Imagine a scenario, for example, a PCI compliance team that is implementing a payment system that you have to store 100% of the logs. So within this scenario, you just skip sampling. But this is very nice for us as well. When it comes to seasonalities and the traffic grows up, we can increase our default sampling percentage so observability stack doesn't grow linearly alongside with the platform itself. We are able to adjust those things on the fly. And it's the default percentage is up to the observability team. But the individual indexes and individual teams, they have the freedom to configure and have their own percentage for sampling. Another thing we do is the write-ahead log. We implement a wall right before sending telemetry to the data sync. So for example, if I have one of my vendors systems, for example, OpenSearch, that is suffering any sort of failure, we see that on the retry, we are receiving failures from the data sync. We just open a circuit break, and then you start writing to an S3 bucket the entire telemetry data, and we have a Lambda function or a set of Lambda functions that backfills this data into the data sync after it recovers from failure. And this is important to mention that to communicate with our engineers, there is an important thing which we are talking about. We are not losing data when it comes to this sort of failure. We are delaying data. It's different things that it's nice to us to have this kind of SLA with our engineers. So we are not losing our data. We are delaying it because we are suffering an outage. So this write-ahead log helps us with it. Also, we have the alerting part where I mentioned it. We use Grafana and allow teams to themselves create their dashboards and their alerts that we have an internal structure for incident management. So they have their systems for incident management, and they do the communication with every on-call engineer. So the alert goes through these other systems and then reach the on-call engineers. And the engineers themselves are able to create and state what are their alerts and what are the interested metrics for them. Well, some tips on the migration step, because we didn't switch a key and then we have a centralized solution and we are now using Open Telemetry Protocol and with this new entire pipeline and so on. One of the important things for us were RFC-like documents, so we call them design docs. So we wrote design docs for this solution, called the entire engineers, all of the teams that write the product itself. They jump in to say, hey, this works for me, this doesn't work for me, I have a problem, I need another protocol, I need a different style of ingestion, I'm not using precisely Open Telemetry, we need help for this and that. So it was really helpful having this sort of strategy and helped a lot throughout the migration step. Also, buy-in from the C-levels, directors, everyone in the company understood that, okay, this is a company shift. This is not something that observability team is trying to push on the engineering teams. So it helped a lot throughout this migration. Also, understanding our customers. At the end of the day, the customer for observability team in our company are the engineers. So we jump and sit together with them, discuss it, and understood individual cases and common cases. So we could draft and design this solution. When it comes to resilience, it was really important to engage our vendors. So how does your data sync, your application fails? How can I prevent failures? And so on. So we had to engage with those vendors in order to try to be more resilient and be up and running. Also, find early adopters was helpful to have some teams that, as any new technology, as any new innovation, there are some people, they say, hey, I would like to be part of it, let me try it. So engage those people, try to bring them close to the team and help you draft and check if the solution is going well and is stable enough for reaching other teams. Well, just a briefly recap. Then we just saw, understood about VTEX and the multi-tenant e-commerce platform. Then we jump into the problem we are trying to solve. And then we draft the solution plus the outcomes we reached with the solution. Then we jump into the architectural part, sharing everything, how we deploy the collectors, how we do our Kubernetes part, and so on, and spoke about resilience, how to keep this application and this new solution up and running. And finally, I would like to say thanks to the Open Telemetry community. This ecosystem enabled VTEX to innovate fast and efficiently. So we are really thankful for that. Thank you, Open Telemetry. And we reached the end of this presentation. And I don't want to stand between you and lunch. So thank you, folks. Yeah.
Thank you, Gustavo. That was an awesome talk. I know we're over time, but I want to give time for 1 or 2 questions. Does anyone have any quick questions? Yeah, Logan.